Hi, it's Lynn again. So this lesson is about solving radical equations. Now this is going to have some similarities to when we solved absolute value equations, and where we had to isolate the castle before we made the positive and negative solution by moving everything over to the other side. Same thing with radicals. We need to make sure that they're safe before we undo the radical. So in this case, we have a square root of 4x minus 3 minus 7 equals 0. So these are equations because they have equal signs. We're looking for answers. So what we need to do, we want to undo the square root, and undoing a square root means squaring it. If it's a cube root, you would cube it. A fourth root, you take it to the fourth power. But you can't do it until it's all by itself. So what we need to do here first is we need to add 7 to both sides. And so we're going to just have the square root of 4x minus 3 equals 7. So now, because this is just one isolated single term that's a square root, we can undo the square root, basically help the x escape so we can solve for it by squaring both sides of this equation. So the square just undoes the square root, so this is just going to be left with 4x minus 3, and this side equals 49. So now it's just an easy algebra equation. We're going to add 3. So we're going to get 4x equals 52, so x equals 13. Now what you really need to do with these, by squaring both sides, sometimes you introduce an answer where you end up with a negative under a square root, and we cannot have a negative underneath the square root because you can't take a square root of a negative number. So we double check and we put this 13 back in, so we have the square root of 4 times 13 minus 3 minus 7 equals 0. You want to check it all the way back in the original equation. So this is 52 minus 3, which is 49. Square root of 49 is 7. 7 minus 7 equals 0. So that checks out. So that's the simplest example of solving square root equations. Not quite, because you have to move the 7 over, but it's still pretty simple. This one is a little bit more complex. So again, we need to isolate this square root. So we're going to subtract x from both sides. So we're going to have negative, because the negative sticks with it, square root of 1 minus x equals negative x minus 5. And there's too many negatives for my taste here. So I'm going to basically divide everything by -1, so that makes this positive, that positive, and that positive. So we're just going to have the square root of 1 minus x equals x plus 5. All right, so now this is safe, so we can square this. It's just one term. So this squares, now this squares. This is where a lot of people make mistakes, because they go, oh, this is just x squared plus 25. It's not. You have to FOIL this. So whenever I see a quantity squared, one trick I do is I just write it twice, which reminds me to FOIL that. So this will just take away the square root. So we have 1 minus x equals x squared plus 10x plus 25. And now this is a quadratic. And now we go back to where we solved quadratics. And so we're going to add x to both sides. And then we're going to subtract 1 from both sides. So we're going to have 0 equals x squared plus 11x plus 24. And now what we know that we need to do here is we need to factor it. So we have 0 equals, and this is just plain x factoring, x and x plus 8 plus 3, because 8 times 3 is 24 and 8 plus 3 is 11. So x equals -8, or x equals -3. And as I said, one of the very important things is to check these answers to make sure that we don't get a negative or something that doesn't work up here because there's a negative. So let's check the negative 8 first in this original blue equation. So the check, so we're going to go negative 8, because that's x, minus the square root of 1 minus negative 8. Always put things in parentheses, equals negative 5. So we have negative 8 minus, and this is negative negative turns into plus, so this is square root of 9, so negative 8 minus 3 equals negative 5. No, this is negative 11 equals negative 5, so this is a no. So that doesn't work. Now we hope the other one doesn't work. We hope the other one works. If it doesn't work, then we get no solution. So let me try this. So the negative 8 didn't work. So I'm going to try the negative 3. So we have negative 3 minus the square root of 1 minus negative 3 equals negative 5. So we have negative 3 minus, and these again turned into pluses. So 1 plus 3 is 4. Square root of 4 is 2, equals negative 5, and that checks. So x equals negative 3 is our only answer to this one. So I have a couple more examples for you that I'll get ready for you. Okay, I'm back. Here's another example. Now this one is a little bit different because there are 2 square roots. So you're like, wait, which one do I isolate? So you can choose which one you want to isolate. In this case, this one's already isolated. So basically what happens is you have to do this whole thing twice. So you need to square one of them when it's isolated. And we'll get rid of that square root. And then you isolate the other one and you get rid of that square root. The hard part is you need to remember to FOIL, and it's kind of complicated foiling. So let's start with this one. This is isolated, so it's okay to square both sides. So that's squared, and this is squared. So remember my hint, is instead of writing squared, I'm going to write root 3x plus 4 minus 1 twice. So I remember to FOIL that. So this side is easy. This turns into just 2x plus 1. This side, you have to FOIL. So the first is this times this, which is like squaring it, so it's just going to be 3x plus 4. And then it's going to be minus root 3x plus 4. The outside is minus root 3x plus 4. And then the last is negative 1 times negative 1, which is plus 1. All right, so let's simplify this side a little bit. So we have the 3x, there's no like terms for that. The 4 and the 1 are like terms. So we're going to have 3x plus 5, hope you can read that, minus, and there's 2 of these like terms. So minus 2 root 3x plus 4 equals 2x plus 1. All right, so that's as simplified as we can get. What we want to do is isolate this now. So we're going to basically do one at a time. So we're going to move all this stuff over here. So we're going to subtract 3x, so we put it under the like term. We're going to subtract 5 minus 5. So we have negative 2 times the square root of 3x plus 4 equals negative x minus 4. All right, so what we can do here, we can actually, remember we changed the signs in that other example, we can make everything positive. So this is positive, 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 basically dividing everything by a negative 1. And now we can square both sides. You have an option here too. You could divide everything by 2, but the problem with that, since this is all one term, we'd get a 1/2 here. We like to avoid fractions if we can. And it's okay to square this as long as this is one term. and not 2 plus root 3x plus 4. If it was 2 plus, we couldn't do that. So this just, with the 2 gets squared and that gets squared. So it's going to be 4 times 3x plus 4 without the square root equals, and remember what we have to do here. I'm going to write it twice, x plus 4. So it's x squared plus 8x plus 16. This is a quadratic again. This is pretty complicated. I get it. So if you want to, you can rewind this, play it slowly, make sure you really understand. But anyway, I'm going to keep going here. So this is going to be 12x plus 16 equals x squared plus 8x plus 16. It's a quadratic. Quadratics always need to be set equal to 0. So let's move all this over. So minus 12x minus 16 minus 12x minus 16. And I'm going to go up over here. So we're going to get 0 equals x squared, hope you can see that, minus 4x. And then these go to 0, so it's just x squared minus 4x. We always want to factor. 0 is x times x minus 4, which means x equals 0 or x equals 4. And we want to check this into the original blue equation. So let's take the 0. So root 3x, so with the 0, and it'd be square root of 4, which is 2. 2 minus 1 is 1. And this is going to be square root of 1, which is 1. So this checks. And if we put in a 4, it's going to be 3 times 4, which is 12, plus 4 is 16. So this is going to be square root of 4. Square root of 16, which is 4. 4 minus 1 is 3. And then if we get 2 times 4, which is 8 plus 1 is 9. Square root of 9 is 3. So 3 equals 3. So in this case, both of them work, but you must check your answers. So those are the 3 examples I had. One was just 1 square root, where you just square both sides and it's a single term. If there's 2 terms on the other side, you must FOIL. And if there's 2 radicals, you need to do the whole process twice. So those are my 3 examples for this. Have fun.